Hi there. So this is my presentation for the AI course. My topic is why anthropomorphic AI will outperform rationality-based AI. So to explain this, let me first start off by giving the definition of AI. So AI can be viewed from two different perspectives: the perspective of anthropomorphism and the perspective of rationality. So in the perspective of anthropomorphism, AI is viewed as how similar it is to human behavior, and while in the perspective of rationality, AI is viewed as how ideal it performs in a certain domain, irrespective of how irrespective of whether it behaves like a human or if or not. Okay. So my main thesis is that when we develop AI, if in the future, if researchers and AI developers focus on trying to make the AI behave as humanly as possible, they are going to see improvements than the trying to handcraft the AI to behave as ideally as possible. So the main reason why I say this is because of current trends and the results, the exciting results that we see from AI research right now. So let me first explain a brief history of AI in certain domains and the problems related to certain approaches, and how we rectify those approaches, how we are rectifying those approaches right now. So let me first start off with the game of chess. So in 1999, AlphaGo, the DeepMind team created IBM's Deep Blue defeated Garry Kasparov in a 12-game match, and with this being the first time a human chess player, human world champion was ever beaten by AI in a match. So the AI brute forced the search tree, and the AI primarily worked by brute forcing and used through the alpha beta search, and it also used an evaluation heuristics to give out what it thinks is a handcrafted evaluation heuristic to assess a position in the game. This was similar to what its predecessors did as well. So, but how this improved on its predecessors was that it primarily focused on improving the handcrafted evaluation function, and the team that created this just mainly focused on making the AI figure out how good a position was or how bad a position was, and improving on its predecessors. So this is what I mean by the rationality based approach, and this is and you can see that the AI developers were primarily concerned with just creating the logic, explicitly creating the logic in the AI. So after Deep Blue, again, the successors still mainly worked on improving on the search the evaluation heuristics, and also tweaked a little bit on the alpha beta, but the principle remained the same. It was that the programmer would work on it was explicitly tell what the AI should do and what the AI should think, and let's just tweak on that. And so now let's see the game of Go. So in the game of Go, this approach was not that successful. This is because the game of Go, in every position in the game of Go, has a lot more moves to consider than in the game of chess, and this resulted in the search depth resulting in not being that deep, and with this approach, even the best AIs were defeated by the amateur level Go players. And and then another domain is mathematical reasoning, and in this domain there was attempts to create mathematical prove mathematical theorems by brute forcing through searching through search algorithms, and this resulted in some success, but partially, but it mainly was not that widely. It was not credited. So one successful example is the Kepler conjecture and the proving of the Kepler conjecture, and another is the Boolean Pythagoras triple problem, the solving of it. So another domain is the domain of table tennis, and traditionally programmers would just use search handcrafted functions to handle stuff like the Magnus effect or elastic collision or gravity air resistance, and this also does not result in good table tennis playing AI. So in all of in this approach, and because of this example, we see problems. We can see central problems to this in all of these domains. So they all use the what I called was the rationality centered approach, where the programmers explicitly worked on telling the AI what to do, and in every step of the way making the AI perform as the AI designer wanted. So the one main problem was that it was exceedingly difficult for the programmer to improve the logic ingrained into the computer program. If you change one aspect of the program, there was a risk that another program would break. Another was that they were like the human developer's job was creating the general model for in every domain. However, a general model would not in all domains. General models did not handle certain edge conditions, and that resulted in the AI always having issues. So, and the programmers could not improve on this because again, the model was inflexible, and if they changed something might break. So how do we fix this? In order to fix this, so nowadays modern AI developers are veering towards fixing many of the issues resulted from the rationality theme AI development from the 2000s and 1990s and even before that. So let's start off with AlphaGo. So in 2016, the world champion of the game of Go, Lee Sedol, was beat by AlphaGo in a 5-game match. So this AI used a completely different approach than what I talked about earlier. So two main differences I want to highlight. Firstly, you used the Monte Carlo search algorithm instead of the typical alpha beta search or any other advanced version of them, and also another difference is that it used a trained neural network to evaluate state positions, states, rather than handcrafted evaluation functions that the programmer worked on. So what happened was that the programmer worked on the developers trained the neural network with many real-life human games to find out the evaluation function and to create a good evaluation neural network, and also train the neural network that would act as a policy head, which was used in the Monte Carlo search algorithm. And because of this, they achieved a result that was not possible, and which was improved drastically on its predecessors. So again, in 2018, DeepMind, the same company that created the AlphaGo, improved on their results and created the and published a paper of the AlphaGo Zero and AlphaZero algorithm. This time they even implemented the same algorithm in the game of chess. So their approach was built on the same algorithm as AlphaGo, but it was slightly different. So instead of training the AI using human input, actual human data sets, the AI was created by just constantly making the AI play against itself in these domains, and which resulted in it having better results than the 2016 version. So in AlphaGo, in the game of Go, this algorithm beat AlphaGo, which was the previous version, and in the game of chess, this actually resulted in the strongest chess AI ever created, and it beat the Stockfish, which was the previous strongest AI, in a 100-game chess match. So this was these two developments of the AlphaZero and AlphaGo and the DeepMinds. You can see how the 2016 version really resulted in a 2018 version, and now even in the game of table tennis, this AI was created that used the same principles and the same logic as the AlphaGo, and it learned to play table tennis by playing against itself, and disregarded the previous approaches of handling area distance, the Magnus effect, stuff like that. And this again resulted in a very good AI, and as you can see, it resulted in the AI having a 95% success rate in the returns, in the balls returned. Another AI is developed from this approach was the Dota 2, in the game of Dota 2. In 2019, OpenAI created an algorithm that beat the best players in the game of Dota 2. Again, this approach was used as reinforcement algorithm to train AI how to play the game, and it was very similar to the AlphaGo algorithm from 2016. So now the most recent and a very exciting achievement of this similar algorithm is in the domain of structural biology. So in structural biology, there's a problem called the protein folding problem. So this is that whenever there's a long chain of amino acids, the amino acids would usually crumble up into a stable structure, and it is very difficult to actually predict what the stable structure will end up given a chain of amino acids. There are many, given a chain of amino acids, there are many stable structures, or only one stable structure, but it's difficult to predict what the stable structure actually will become. So this was a research topic in AI for quite a while, and there was a competition called the CAPS competition. We used to benchmark the predictions from different teams across the world. So in 2018, the DeepMind, the same team, achieved a very successful result using the same principles as the AlphaGo and AlphaZero. They created an AI called AlphaFold, and this resulted in a success rate of 50%, which is much better, which is the best result any AI had ever gotten. And recently, in late 2020, they improved their performance drastically, creating an AI that reached a performance of 90% in the CAPS competition. This AI was called AlphaFold 2. So this AI was so significant that it is even called the biggest breakthrough in structural biology in the past 20 years, and it has a lot of implications, like finding out what causes the Parkinson's disease or diseases, or even recently the COVID-19 SARS protein. It was able to successfully predict the structure of that was resulted from the amino acids that was created from the that created the SARS protein. So as you can see, in the past few years, ever since AlphaGo, there has been exciting research in human-centered AI and data-driven AI, primarily facilitated by the rise of machine learning in the past decade. Because of these advancements, I believe that the human-centric AI will outperform many in the previous rationality-based AI were in many other domains as well, and the issues that we had earlier with the previous approaches will be rectified by these data-driven and machine learning approaches, which is primarily concerned with finding patterns and making the algorithm behave like what humans would do, and treat the problems like how humans would treat problems. So this is where I conclude my presentation. I'm really excited by this development in AI, and thank you.